We've been working with the home prices data set, and in this video we take the analysis one step further and we build what's called a regression model. And these are the key pieces of information that I want. At this point I should be able to identify the correlation, which is called multiple R in Excel, so we can read that and see that there's a strong association between the home price and the assessed value. Now the other piece I really need is this group of coefficients. The coefficients determine the model that we use to make predictions for one variable based on the other variable. Okay, so negative 122.34 is the intercept, 1.78 is the slope. Intercept in this case is not especially meaningful, right? Because it's telling us the value, the home price when the assessed value is 0, the predicted home price when the assessed value is 0, which is just not meaningful, because if we have an assessed value of 0, there's no reason we'd be making predictions at all. We're not going to encounter data that low or anywhere near that low in value. Okay. The slope, however, is very important, and what you're going to be asked to do is take these coefficients and build a model. So let's see if I can get okay, so the important things to be able to do based on this output are, first of all, build the equation of the model. Okay, so take the coefficients, take the intercept, and that goes first in statistics when we're building a model. The coefficient goes first. It's not quite like y equals mx plus b. It's formatted slightly differently. Okay, and then I take the slope, and that goes in front of the predictor variable, the aka explanatory variable, also known as the independent variable. Okay, but in statistics, rather than using y's and x's, we need to communicate the context a little bit better than that. So a good way to present the model would be to say that predicted price, and we use the hat to indicate that it's predicted. Predicted price is equal to negative 122.34 plus 1.75 times the assessed value. Okay, so price and assessed are the variables, and the numbers here are the constants or coefficients. Okay. And interpreting the coefficients is one of the more critical things you need to be able to do. In this case, we know that the intercept is not meaningful, but the way to interpret it would be like this. The model predicts that a home value with an assessed value, a home with an assessed value of $0 will have a selling price of negative 122.34, and that's in terms of thousands of dollars. So we could say about negative $122,000. Again, not meaningful. The slope is important. The model predicts, here's how we interpret it, right? The model predicts that for each increase of one, and that's $1,000 in assessed value, the selling price will increase by 1.78, and that's in thousands of dollars. All right, so I might make that a little bit more easy to interpret and just say this tells us that each increase of $1,000 in assessed value corresponds to a $1,780 increase in the selling price. And then we can see how this would be useful to realtors, right? Knowing that the way the prices behave relative to the assessed value is very important. Okay, now what else can we do with our model? The next thing to go over is making predictions, right? So this is exactly the position a realtor might be in. If we have a home that is assessed at $152,000, what would we predict the selling price to be? Well, we think of that $152,000 as the observed assessed value, right? And we have no observation for the selling price for this home because it hasn't happened yet. So let's predict it with the model. So calculating that out, we just plug in the 152 right here, and then the Y predicted, the predicted price is 148.22, and that's again in terms of thousands of dollars. Okay, so that's making predictions. Now lastly, here's an exercise. If we had a home that was assessed at $16 million, right? Because here I have the 16,000, and that's in terms of thousands of dollars, so that converts to 16 million. What would be the predicted selling price? And I believe if we do this, okay, so let's, here I am working this out, right? I plugged in that 16,000, right, which is 16 million, and I got 28,357.66. So I'm understanding that that's 28 million approximately, right? So a home with an assessed value of 16 million is predicted to sell for more than $28 million. Okay, so this illustrates something that's a caution that everyone should remember when using regression models. Predicting beyond the range of data is called extrapolation, and it's a dangerous thing to do because we don't know if the model that we've built based on the data, we don't know if that model extends all the way to these high values that I'm trying to make predictions for, right? So making predictions far beyond the range of the data is called extrapolation, and it's something we shouldn't do.